Hi Chemistry, welcome to day 3 of acids and bases. For today's spell work, I'd like you to take a look at the formulas or name of each of these acids and bases. I have both mixed here. And I would like you to write out the formulas from the names that are here. So I have hydrophosphoric acid, I have ammonia, I have nitrous acid, and baking soda. So you want your green sheet because some of those are written on the bottom. I need you to name a strong and a weak base that we discussed yesterday. I'd also like you to tell me what an amphoteric substance is. Speaking of a substance that can be either an acid or a base, let's talk about the self-ionization of water and how water acts. Pure water is neutral, and it can ionize itself to form OH negative and H plus, H3O plus ions in small amounts. So we have regular water that can break down into this. It can be written this way as well, where you have the hydroxide and hydronium ions. The universal indicator color is green in neutral solutions. So water can actually break down and ionize itself, and that's why we use deionized water often when we're doing chemistry reactions. How do we measure the amounts of OH and H plus in a solution? It's the pH scale. It measures the concentration of H plus ions in a solution. I want you to look at that sheet that I've put on the assignments. I've given you, it said pH and introduction, and there's several sheets that give you these formulas. We're going to use these formulas to work out some of the problems and those problems on there. So the POH scale measures the concentration of OH ions. And so the pH can be found by the negative logarithm of the H plus concentration. And the POH is found by the negative logarithm of OH minus. The pH scale was invented to make the numbers easier. So we know that pH plus POH is 14. And that's why we have a scale of 14 set up. Acids have a pH below 7. Bases have a pH above 7. And neutral pH is equal to 7. Again, these formulas are given on the other sheet, and they'll be used to do some of the problems later. So just to give you an idea of certain things that are acidic and basic, I've have a pH scale here with some things like battery acid. Acid rain can be in this range. Fish die if it's this strong of acid rain. Fish reproduction is affected if it's just slightly acidic. The normal range for precipitation is slightly acidic. Again, as I discussed, we have some rocks on riverbeds that are designed to neutralize the water before it hits the river through the watershed. Milk is pretty neutral. Normal range for stream water would be right in here. Baking soda and seawater are basic. Milk of magnesia, ammonia, and then lye is also very basic. Here's just another scale, the 1 through 14, that can give you an idea of the different things. Like bleach is basic. Distilled water, again, would be neutral. We have pure rain that is, again, slightly acidic. Acid rain would be up here. Normal rain is just a little acidic. Coffee is acidic. Most of your foods are going to be slightly acidic. Okay, again, there's another example to show you. This would be Nair hair remover. It's very, very basic. Can cause chemical burns. You should always test your skin first before using it. Then we have our foods that are acidic. And then pure water would be our neutral. And egg white is actually basic. All right, so let's take a look at these problems. Let's calculate the pH of a 0.001 molar solution of HCl. Because it's a strong acid, we know it's going to dissociate completely, so we can use this number for our value of H+. And so the H+ is 1/1000th of a mole, And so the pH is the negative log of 0.001, and I wind up with a pH of 3. What about the POH? This is a similar problem, but we can use up here, we can use the fact that pH plus POH is 14, and I can just subtract the 3, and so I can see that the POH would be 11. So pH is less than 7, so it's acidic. POH is 11 here. What's the concentration of the OH negative ions in this solution? In this case, I know that the OH concentration is equal to 10 raised to the negative POH. And if I have the negative POH of 11, I can just put that in the calculator, and I can find that there are hardly any OH ions. It has 1 times 10 to the negative 11th molarity of OH. All right, let's take a look at number 2. Now we're going to calculate the POH of sodium hydroxide if the pH is 8.50. 8.5 would be basic. There's a couple of ways we can get there. First, I'm going to go ahead and go from the if I know the pH is this, let's find the POH. So I'm going to subtract 8.5 from 14, and I get a POH of 5.5. Now, if I want to find the OH solution, I can use the same equation that I used above. And so that's basically 10 to the negative 5.5, and you're going to see that this sodium hydroxide has 3.16 times 10 to the negative 6 moles. What is the concentration of the H plus in this case? So to figure that out, I'm going to go back. Be able to see that. Let's see if we can see it here. All right, so for this one, you can see that we have H plus equals the negative pH, and we figured out the pH. We would figure that out because it was given in the first part of the problem. So we have 3.16 times 10 to the negative 9th moles of H plus. Clearly there's more OH than H plus. This would be considered weak at this point. Thank you and have a great day.